Hi, okay, this is an additional maths video. This is a method for solving a quadratic equation called completing the square. We're not going to go as far as actually using it to solve quadratic equations, but I'm just going to introduce you to the technique of how we would do that. And what we're going to try and do is rewrite this function x squared plus 8x plus 19 as one bracket all squared, okay, on the left hand side, and that opens up then lots of possibilities, things that we can work out, things that we can say are true, and actually it's where the quadratic formula at GCSE is sort of derived from. Okay, so if we have a look then, we're trying to get just one single bracket squared, like I've got up here, out of x squared plus 8x plus 19. Okay, and the trick is to just halve that middle term. Okay, so I know that to make x squared, I'm going to need to have an x. And remember, when you've got a bracket being squared, what you're really saying is it's two brackets side by side that need expanding using FOIL or whatever method you're using. So I know I need an x because x times x is x squared. And then I know that to get an 8x out of this, half of 8 is 4. So I need to put a plus 4 inside my bracket as well. Now then, if over here I actually do the expansion of x plus 4 all squared, which is x plus 4, x plus 4, then we get our x squared, which is fine, we needed an x squared. We get 4x, we get another 4x, and we get a 16. So we've got x squared, which we wanted. We've got 8x, which we wanted, but I've got a 16 and I needed a 19. Okay. Now, if the numbers are nice, what you can say is, well, if it naturally gives me a 16, but I want a 19, I just need an extra 3. But a better method that will help you in the longer run when it gets more difficult is to say, well, I don't want this plus 16, so I'll take away 16, and I do want this plus 19, so I'll write in a plus 19 afterwards. Now, of course, that is going to give you a plus 3. Okay, so we're going to get x plus 4 all squared minus 16 plus 19 is plus 3. Okay, which means now if I expand out x plus 4 all squared and I add 3 to my answer, so that's effectively like saying over here, I'm going to add 3 to my answer as well, I should hopefully get what I started with, which was x squared plus 8x plus 19. Okay, now I think I've got an extra line of brackets here which I don't need, so let me just rewrite all that again very quickly. And I've got some notes here on this as well. So in this bracket then, where we've got x plus 4 all squared, I've got my notes, can either be 0 or positive and never negative. And that's because even if I put something like minus 6 for x, minus 6 plus 4 is minus 2. But then when I square it, minus 2 squared is positive 4. Okay? If I put in x is 7, 7 add 4 is 11, 11 squared is 121. Okay? So the smallest that I will be able to get this bracket is 0. And to get it to be 0, I would need x to be minus 4, because minus 4 plus 4 is 0, and 0 squared is 0. Okay? With my plus 3, if the bracketed part of this expression, all of this, has come out as 0, well, 0 plus 3 is 3. And I will never get a smaller answer than 3, because any other value I put into my bracket for x is going to come out positive, and then when I add 3 to it, it's only ever going to get bigger. So 3 is what we would call the minimum value for this expression, okay, or for this function. It will never get smaller than 3. That's impossible. To be smaller than 3, my bracket, when I square it, would have to come out negative, and that can't happen when you square a number. Okay. So what we can say then, I've got a set of axes down here, is that I know the minimum value of this graph is 3. And to get that minimum value of 3, x would have to be minus 4, which is there on my x-axis. I haven't laid my axes yet, but x and y. So this is the minimum point of my graph. It's a positive quadratic, so it's a smiley face shape, okay? And there's my minimum value. Okay, I can put that in. I also know, if I scroll back right to the top, I do actually know my y-intercept as well. It has to be plus 19. So I can actually put a little bit more information on as well. I know this graph crosses at 19. It's a bit wobbly, but you get the idea. Okay, so to find the minimum value, you look for what value of x do I need to put into my brackets. So if the bracket says x plus 4, then x needs to be minus 4. Okay. And what happens when I put minus 4 in? I get 0 for the bracket, 0 plus 3 is 3, so my minimum point, my minimum value. It also tells me I've got a line of symmetry down here. This would be x equals minus 4, okay? And it's actually a quick way of finding the minimum point, which otherwise you could do by differentiating and setting it to be 0. So where is the gradient? 0. Okay, let's have a look at another one. So this time we've got x squared plus 6x plus 2. So our first job is to, well, first of all, we definitely need an x, because x times x is x squared, and then a plus 3, because that's half of 6. Okay. If I come down here now then x plus 3 all squared gives me x squared plus 3x plus 3x plus 9. The x squared, that's fine. The 6x is fine. I want that and I want that because they're in my question there and there. I need those. I don't need this plus 9. In fact, all I really want at the end of it is a plus 2. So x plus 3 all squared. Now the easiest way to deal with this, like I said before, is to just say, well, if I don't want the plus 9, that's automatically going to come out of expanding those brackets. I can take off the 9 that I didn't want, and then just add on the 2, which I do want. And when you tidy that up, then you're going to get x plus 3 inside your bracket, minus 9 plus 2 is minus 7. Okay, so for this question now then, to find my minimum value, so first of all look at your bracketed part and you say, well, how do I get that bracket to come out as 0? What value of x would I need to pick? So my value of x would be x equals minus 3, because minus 3 plus 3 is 0. And if I can get all of this bracket to come out as 0, then my minimum value, 0 take away 7, is minus 7. And I can show that on a graph this time. So x is minus 3. The minimum value is minus 7. So I can put that down here, minus 7. And I can plot that as a point. That's my minimum value. Do I know my y-intercept? Scroll back up. Yeah, plus 2. So that's it. Y, x. And I can now sketch this out. It will look something like that. Okay. And again, this is now a stationary point. You could have done dy by dx equals 0 to find that, but this is actually a quicker method anyway. Okay. If you wanted to find your roots where it crosses the x-axis, then put it equal to 0 and solve it now then, okay? If I do one more in this video then, this time I've got a minus 4x in the middle. That doesn't make actually much difference at all, okay? Half of minus 4 is minus 2. X minus 2 x minus 2 is going to give me x squared minus 2x plus 4. Be careful when you do minus 2 times minus 2. So that's x squared minus 4x plus 4. So x squared minus 2. And then, as I've done on the previous examples, I don't want this plus 4. So just take off the plus 4 that was automatically generated by the bracket, but then put on the plus 11 that we do want, and then tidy it up. Okay, and again you'll get your value of x from the bracket and your minimum value from whatever minus 4 plus 11 is. Minus 4 plus 11 is plus 7. Okay. Now the biggest difference really with the minus 2 inside the bracket is now that when I put it equal to 0, x will have to be positive 2. So x is positive 2 and my minimum value is 7. And have I got a set of axes to draw that? Yeah. Okay, so our minimum value is when x equals 2 and the minimum value is 7. So when x equals 2, the minimum value is 7 as a coordinate. It would be 2, 7. Have I got a y-intercept? I do. It's 11. So something like that with a y-intercept of 11. But it's this minimum point, getting the value of x and finding the minimum value, which is the most important thing at the minute for you. Okay. And that's it. That's an introduction to completing a square, and just being able to do that will get you through additional maths, and then it's built on further then at A-level maths, where you actually then start to solve it. Okay, you'll need to use some surds for that a lot of the time, and how you would deal with having a coefficient of x squared as well.